So what do we mean by the nth rule? Well, it's not the recurrence relation, okay? This rule is in terms of n. Before we did the recurrence relation where we had v of n plus 1 will equal our v of n, and we're either adding or subtracting something, that d. Today, we're not doing that. We're writing the rule with n only. So they could ask us to do it in this way, or they could ask us to do the recurrence relation. So we need to learn both ways. Okay. We've still got v of 0. Okay, that's still the initial investment, and we're going to put it in there. We have an interest rate, and then we've got our rules. I'm going to show you how to do these rules again. I'm not going to use these rules. I'm just going to make you think about it. Okay. Okay, let me just clear this. There's a flat rate depreciation. Okay, flat rate, it's going down. Great, someone else has joined us. It's flat rate just means, remember, the same amount every time. Okay, and decay means it's going down. Linear means it's a straight line. Again, we'll do this. We've spoken about unit cost. Okay, I'm going to show you how to do the unit cost. Sometimes the rules are necessary, sometimes they're not. You can think about it getting in your head. Okay, well, let's do example 1. Okay, the following recurrence relation can be used to model a simple interest investment. V of 0 is 3,000, V of n plus 1 equals V of n plus 260, where V of n is the value of the investment after n years. Okay. Part A, what is the principal of the investment? Well, that's pretty easy. The principal means, what did we start with? Well, we have started with $3,000. So the principal is $3,000. The second part says, how much interest is added to the investment each year? Well, there's our interest, 260. So our interest equals 260. Any questions there for part A? Okay. Part B. I'll do part B down here. It says, write down the rule for the value of the investment after n years. Can you see that there is no words that says write down the recurrence relation? This is the recurrence relation. All that. Okay, that's my recurrence relation. But part B wants the rule in terms of n. So let's think about what's happening here. We've got some money, $3,000 in the bank. At the end of the first year, they give us $260. At the end of the next year, the second year, they give us another $260. At the end of the third year, they give us another $260. So every year, at the end of every year, they're giving us $260. So we're going to write that in a rule in terms of n. Okay, so V of n, because that's what it says, V of n, okay, equals $3,000 is our starting salary. Okay, so 3,000, remember the rule says up the top, V of 0, there we go, 3,000, plus every year they're giving us $260. And of course, we're going to times that by n. Okay, n being how many years, and it says the n being the years. So when we put 1 in there, we're going to have 3,000 plus 260 times 1. Put 2 in there, 2 years, 3,000 plus 260 times 2. And we've got our rule in terms of n. Any questions for part B? Okay, part C. Part C says, use the rule to find the value after 15 years. Okay, well, now that I've got my rule, part C, I'm going to find the value after 15 years. So n equals 15. So we've got 3,000 plus 260 times 15. Now, I don't know that off the top of my head, so I'm just going to get the calculator out and do it, and you guys can do it at the same time. 3,000 plus 260 times 15 is 6,900. So after 15 years, this investment is worth $6,900. Any questions there for you guys so far? Part D says, oh, let me just bring that a bit lower. Part D. Use the rule to find the value of the investment when it first exceeds $10,000. So we have to find our N, but we know that we want it to be $10,000. So let's put the V of N equal to 10,000, just equal to it. We know it says more than 10,000, but we'll put it as equal to it. And then we're just going to solve on our calculator. So I'm going to leave a little space here so I can write the word solve. So 10,000, that's what we wanted, equals 3,000 plus 260 times N. And because I want to find N, I'm going to put solve instead of rearranging the whole thing, comma, for N. So I'm just going to solve my N. So when I do that, I end up getting an answer of 26.92. That's not our answer because the question says when it first exceeds. So more than 10,000. We just solved it when it equals 10,000. So it's going to be more than 10,000 when N equals 27 years. You can't go down to 26. It wouldn't have reached 10,000 at 26 years. It has to be at the 27-year mark. Any questions now? I haven't got room to write it in by, the value of the investment first exceeds $10,000 27 years later. Okay, well, after 27 years, I don't have that space for it, but it should be doing it in words. But in the exam, you don't need to do it in words, just like this is enough. Okay, just in the SAC, make sure you finish it off properly if we ask you. Any questions with example 1? Okay, in case anyone's writing anything down, I'll clear it soon. I remind you that these videos that I'm doing are up on our Google Classroom. I would like to share them with the rest of the students in our school. I won't ask to put them up on my YouTube channel because of your faces, okay? But if I got rid of your faces, I'd put it up. But that's fine. So if you give me your permission, I will share these with the rest of the staff so that everyone in our school can get them. Okay, but I'll send you an email and you can say yes or no, so you don't have to say it here. And if it's one person says no, then I won't do it. It's fine. Okay, I'm going to clear this and move to the next example. Okay, example 2. Okay. Amy invests $4,000 in a simple interest investment of paying interest at the rate of 6.5% per year. Use a rule to find the value after 10 years. So we have to find our rule here. So let's first get our original amount of money, and it's $4,000. So we know that. $4,000, that's how much Amy puts in there. Okay. Now, this investment is going to make her money. It's going to give her interest, and they're giving her interest 6.5% per year. So how much interest is that? So let's work this out. Interest that she gains every year equals 6.5% of the $4,000. So let's work that out. 6.5 divided by 100 times 4,000. Okay, so when we do this, and again, I'm going to move to my calculator so I can do it. 6.5 divided by 100 times 4,000, I get $260. Okay, so now I'm going to write my rule. And I want the rule in terms of n. It doesn't say to do a recurrence relation, so I'm not going to do that. So I'm going to write V of n equals the original amount, which was $4,000, plus $260 every year. Is everyone happy with that? Now it says find the rule after 10 years. So n equals to 10 here. So I'm going to go V of 10 equals 4,000 plus 260 times 10. Now you can just, you can work that out. That's not an issue. Or you can just use your calculator to work that out. We're going to get V of 10 equals $6,600. So after 10 years, investment equals $6,600. Any questions on that one? We're still one person short. I'll work that out. Okay. I'll get rid of it in about 10 seconds. I'll scroll later. Okay, example 3. It says using a rule for the flat rate of depreciation of an asset. The following recurrence relation can be used to model the flat rate depreciation of a set of office furniture. Where the V of n is the value of the furniture after n years. Okay, part A, what's the value of the initial value of the furniture? Okay, everyone, you got 5 seconds to write that down. Initial value of the furniture. 5, 4, 3, 2, 1. Okay, what is that initial value? Come on, what's the initial value?
$12,000.
$12,000, right there, 12,000. Thank you very much. 3 zeros. Okay. Well, how much does the furniture decrease in value after every year? I'm just going to write that as D, okay, instead of writing all that because it's on the screen. So how much does it decrease every year?
1,200.
Right, correct. There it is there. We don't need to write the negative. The negative means it's decreasing. So it's going down every year, $1,200. Okay. Part B, write down the rule for the value of the investment after n years. So recurrence relation is what they gave us. We're going to write it in terms of n. So the value after n years equals $12,000 minus $1,200 times n. Any questions so far? That's all good? Okay, let's move on to the next one. Use a rule to find the value of the investment after 6 years. Well, we might as well use the rule that we've just written because that's easy because we can find the value after 6 years just by putting n equals to 6. So 12,000 minus 1,200 times 6. Okay, so I'm going to work that out on my calculator. Minus times 6, and I get $4,800. $4,800. Okay. Any questions there from anyone? Anyone got a question? Okay, I'll move on. Let me clear this. We're up to D. How long does it take for the furniture value to decrease to 0? So we had our rule of V of N equals 12,000 minus 1,200 times N. We want this value to be 0. So I'm going to put 0 equals 12,000 minus 1,200 times N. And again, because we're solving for N, I'm going to put solve on my calculator for N and get that answer. So I'm going to ask you guys to do it as well. Okay, will I do it? Solve new algebra. Solve that N, comma, N, and I get, no, helps if I put equal to 0. N equal to 10. Hopefully you guys got 10 years as well. Any questions on part D? Okay, part E. Does a photocopy in the office cost $6,000? When new, its value depreciates at the flat rate of 17.5% of its new value each year. What is its value after 4 years? Okay, well, we can do this, not a problem. We can write down the rule straight away because we know that it costs 6,000. Let's see what it depreciates by. So let's work out our depreciation. It goes down 17.5% of the $6,000. So 17.5 divided by 100 times 6,000. So let me get what that is. And that is 1,050 unless I've made a mistake. So the value at any time equals 6,000 minus that 1,050 every time. And now we want V of 4 after 4 years. So V of 4, 6,000 minus 1050 times 4. And I get the value after 4 years is $1,800. Any questions on that one? No? All right, let's move on to the next part. Clear this. Example 4. Okay, hair dryer in the salon was purchased for $850. That's my initial value. Value of the hair dryer depreciates by 25 cents for every hour that it's being used. Let VN be the value of the hair dryer after N hours of use. Okay, write down a rule to find the value of the hair dryer after N hours of use. Okay, so let's do it. We need to write down our rule. Value after N hours equals its initial value purchased was 850 minus it's going down 25 cents for every hour. And remember, N stands for the hours of use. So 25 cents, we've got to be careful here because 850 is in dollars. 25 cents, we have to write as dollars. So 25 cents, we're going to write it as 0.25, $0.25. So 0.25 times N. Okay, any questions on that one? That's all good. All right. What is the value of the hairdryer after 50 hours? Okay, so we want value after 50 hours because N stands for number of hours. So we got 850 minus 0.25 times 50. Okay, just work that out on your calculator and see what we get. And I got $837.50. I got 0.5, but please do not write it as 0.5, write it as the 50 cents. It's very important. Any questions on that part there? No? Okay, let's continue. So I'll clear this. Part C. It says on average, the salon will use a hairdryer for 17 hours each week. How many weeks will it take the value of the hairdryer to halve? Okay, so I've got to go back and get my rule. So I've got my V of N was equal to 850 minus 0.25 times N. Okay. Now we want the value. We want to know how long it takes for it to halve. Well, 850, it's what it's worth divided by 2. Let's see what we get there. 850 divided by 2. That's what half means. So we've got to go for 425. So we want to know 400 when it reaches $425. So that's what I'm going to put in here. 425 equals 850 minus 0.25 times N. Now this 17 hours will come in because it says how many weeks, and every week is 17 hours. So let's just work out our N first, how many hours it's going to take. So again, I'm just going to do my solve for N to make it easier. So let me do that. Menu, algebra, solve. Okay, 425 equals 850 minus 0.25 times my N, comma, N, and I get N equals 1,700. That's hours. Oops. Hours. Okay, that's how many hours it takes, but that's not what the question says. The question says how many weeks will it take? Now we know that there are 17 hours that it's being used every week. So we're going to get our weeks, we're going to get all the hours, 1,700, and we're going to divide by 17 because it's 17 hours every week. And when we do that, we get 100 weeks. So it's going to last 100 weeks before it's halfway, half the money. Any questions with that one? No? Okay. Clear this.